Right. So here 2 comma 5 is the finished. So 2 comma 5 and 2 comma 6 means which alpha carbon forms in diketones. Carbon ion means outer. So outer alpha carbon forms carbon ions are involved in the nucleophilic additions, right? And if you go for 2 comma 7 and 2 comma 8, so two more are there. So 2 comma 7 and 2 comma 8, so which alpha carbon forms carbon ions where it is added, right? I'm taking the 2 comma 7. So 2 comma 7 means CH3, right? C double bond O, 1 2 is the second place, and it is the third, 4 5 and 6, and it is the sevens. Now we have to go for that. What is the position of this one? One, two, third carbons. It is a 4, 5, 6, 7, and 8. Now check the positions 2 comma 7s. So here it's a 2 comma 7s. So the positions are of ketone is 2 comma 7s, like 2 comma 7 or 2 comma 8, whatever the position you can take it. Which alpha carbon is involved? Now we have to check it that 1, 2, 3, 4, 5, 6, 7, 8. So total number of carbon atoms are 8. So for example, it is a carbonyl group, mine, it is a partial negative, it is a partially positive. It is also symmetrical diketones. But here you can go for here, this side, it is alpha carbon, it is alpha carbons, right? First I am checking with inner alpha carbons. Inner alpha carbon forms carbon ions and H plus is added here, carbon ion is joined here. What type of ring is formed? We have to think in both the cases, inner and outer. That is a very important here. If you take inner alpha carbon forms carbon ion, means this carbon ion is joined to electrophilic center, right? And hydrogen, acidic hydrogen is added to the carbonyl oxygens. And if you go for inner alpha carbon means 1, 2, 3, 4, 5 member ring, right? Similarly, we have to check with outer alpha carbon also. Here is outer alpha carbon is that it is inner. Outer alpha carbon forms carbon ion means 1, 2, 3, 4, 5, 6, 7 member ring, right? 5 membered and 7 membered, which one is more stable means, so 5 membered ring is more stable than 7 numbers. So that's why you have to go for the first priority is 5 membered. It is a major product, more stable product. That's why here inner alpha carbon is involved in nucleophilic additions or forms carbon ions. Now a hydrogen is joined to here, and carbon ion is joined to carbonyl carbons. Now check it, 1, 2, 3, 4, 5. So it forms a 5 member ring in the presence of alkali. You know that aldol means generally we are taking the aqueous base or aqueous alkali. And to form that is number 5 membered. So 5 membered means make that cyclic form, because in examination they are not giving that all carbons complete structures. They are giving the cyclic structures line system. Right? Here is carbonyl carbon is inner. I am taking this is the carbonyl carbon. One point we have to fix it. Right? It is a carbonyl carbon CH2. It is joined to here nucleophilic center. So here is joined means here is OH group. It has the methyl group is there. Whatever the group, it is a methyl group. Right? If this carbon is added to this carbon means a 5 member ring. Right? This carbon side, what is there? Which group is there? Side C double bond O is there and methyl group is there. So don't forget this branches or linking, right? CH3C double bond OH. Right, now we can go for, it is a main functional group. It is alpha carbon, it is a beta carbon. So beta hydroxy keto or carbonyl compound is formed. It is produced considered as aldol. So aldol product or intra aldol product. So intra means within the molecules, so that aldol condensation is possible, aldol reactions. So followed by elimination of water to get stable product. So that is the same 5 member ring, that the 5 member ring. Here is C double bond O and methyl group, right? Where with for 5 bond forms 5 bonds. Here beta carbon OH group, alpha carbon hydrogen is a tertiary hydrogens. So both are eliminated to form conjugated product. Here double bond, here is methyls. So this is the major product and stable product. So this is the major product will be formed. So if any other products means that is wrong. So this is the your correct answer. This is a major product. Major product will be 5 membered ring and conjugations. Keto group and is resonance or conjugation with double bond, single bond, double bond. So conjugation means a negative charge. This pi electron shifted to form double bonds. Right. So it is the 2 comma 7s. If you go for 2 comma 8, so 2 comma 8 means we can expect. So 2 comma 7 means the 5 membered ring. If you go for 2 comma 8 means the 6 membered ring. It's a similar procedure. If you go for 2 comma 7 8 means we are getting the 6 membered ring is formed. We can try it, right? Right. Next, aldehyde and keto functional groups. Suppose one is aldehyde, one is ketone. Right. Now we can take it one aldehyde, one is ketones. Right. This is a very important case. It's a different groups are we are taking. One is CH3, C double bond O, and CH2, and CH2, and we can go for C double bond O and H. Right. So now it is one case. 1, 2, 3, 4, 5. Right. And if you take one more is CH3, C double bond O, and CH2, and CH2, and CH2, C double bond O, H. Right. And one more case is CH3, C double bond O, and CH2. Next, here also CH2, here also CH2, and CH2, C double bond O, H. Right. So like that, we can go for some other example also. We can go for CH3, C double bond O, CH2, 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 C double bond O, H. So here one is aldehyde, one is keto group. If you go for here means 1, 2, 3, 4, 5. It is the position is 1 comma 1 comma 4 positions carbonyl groups aldehyde and ketones. If we go for here means 1, 2, 3, 4, 5, 6. It is 1 comma 5. If you go for here means 1, 2, 3, 4, 5, 6 and 7. It is 1 comma 6. If you go for here is 1, 2, 3, 4, 5, 6, 7, 8. It is 1 comma 8. Right. Suppose if you take this example, so what is your products? OH minus alkali, OH minus. If you go for that, OH minus. So what are the major products are formed? If you go for inner, because of compulsory, its aldehyde group is more reactive than ketones. First of all, we have to remember this as aldehyde functional group is more reactive than ketones. Because of here, keto has a bulky alkyl group, steric hindrance, and electronic factors. We know that aldehydes are more reactive than generally keto functional groups. So compulsory is a more reactive means it's a substrate. It is a nucleophilic addition here is partially negative. It gets a partially positive. So compulsory carbon ions is doesn't form near to the aldehyde functional groups. Only keto near alpha carbons forms carbon ions here or here. Suppose if it forms carbon ion, so 1, 2, 3. So 3 membered. It is unstable. You know that is steric standard. Next, if you go for fifth carbons, 1, 2, 3, 4, 5. This is a 5 member. So if it forms carbon ions, it produces the product. Alpha hydrogen is joined here. So what the product will be formed means it is a 5 membered aldol product will be formed. And CH is joined here means directly I am getting that OH. Suppose if it is the CH2 group is joined to here means, so what is the next group? CH group next group will be should be it's a keto group. Right? So finally aldol condensation product will be formed like double bond O here keto. This is the major product. But if you go for 1 comma 5 positions, so 1 comma 4 means outer alpha carbon forms carbon ions in keto. Right? Here also aldehyde and ketone is there. It is a more reactive compulsory. It's a nucleophilic addition is takes place here. It is a negative part. It is a positive part. Right? Here keto group near alpha carbon forms carbon ions. Here 2 alpha carbons are there. If it is forms carbon ion means 1, 2, 3, 4. 4 number is unstable. You know that. And if you go for this side, left side carbon, so 1, 2, 3, 4, 5, 6 membered. So it can form that 6 membered ring. So go for the 6 membered ring. Right? If it is a methyl group, carbon ion is joined here means adjacent which group is there? It is a keto group is there. Here is OH. Right? Here hydrogen is also there. So it is aldol product, intra aldol, followed by elimination of water molecule to get more stable product, double bond O and here. That is the major product. If you go for here, 1 comma 6 and 1 comma 8 or 1 comma this. So 1 comma 7 can take it. It's not 1 comma 7. Now we have to check it here. So basic mediums. 1, 2, 3, 4, 5, 6 position. 1 comma 6 positions. Aldehyde and ketones. Now which alpha carbon is involved? Suppose if you take this one, 1, 2, 3, 4, 5 membered. So stable, 5 membered stable. Now one more case is there. Methyl group. This side means 1, 2, 3, 4, 5, 6, 7. 7 membered. 5 membered and 7 membered. 5 membered ring is more stable than 7 membered. That's why here is this alpha carbons forms carbene ion joined to electrophilic center, and alpha hydrogen joined to oxygens to form 5 membered ring is forms. So we have to go for the 5 membered ring. Simply can go for the 5 membered ring, right? Suppose this is the carbene ion means what is the carbene ion? After carbene ion it is linking is C double bond O. Here is methyl group is there, right? Here is added to the carbonyl carbon means we are getting that OH. So you know that elimination of here again to form aldol product will be formed. Right? If you go for here also inner or outer, here is outer. If you go for inner, it is a inner alpha hydrogens or inner alpha carbon is involved formation of carbon ions. If you go for here also same 1, 2, 3, 4, 5, 6. So if you take this one means it forms a 6-membered ring. If you go for this one means it is forms a 8-membered. So 6-membered and 8-membered, which one is more stable means it forms a 6-membered is more stable, right? So 6-membered is more stable means here is the alpha carbon means C double bond O and methyl group, and this methyl group is joined to that carbon ion is joined to here means it forms carbon ions OH, right? OH is forms and here hydrogen is available. So this is the aldol product. So elimination of water molecule to form intra aldol condensation product is possibilities are there. This is very important. So while giving that any questions, any type of questions, first we have to check it carbonyl functional group is present like aldehyde or ketones. So first we have to check it. So intra is possible or not in the presence of basic mediums. Like sometimes they are giving sodium hydroxide or potassium hydroxide or aqueous alkali or dilute alkali. So different names they have to mention it. If alkali is mentioned or OH minus is mentioned or sodium hydroxide potassium, it means we have to check it intramolecular aldehydes. So intra means minimum 2 aldehyde group or 2 keto groups are required. Like not only for here I taking one is aldehyde, one is ketones. If you take both are aldehyde functional groups are present in different positions, check it for this alpha carbons or carbon ions. So generally in these reactions, what number means that you had it is very important. 5-membered rings and one more is or 6-membered rings. Only 5-membered and 6-membered rings are possibilities are there, but a few exceptions are there. If sometimes they go for 7-membered also possibilities are there. So where it is forms the 7-membered rings means if you go for aromatic compounds like is the benzene structures, right? Here they are giving that CH2 and CH2 and C double bond O H is given, right? And one more is here is CH2, here is CH2, C double bond O H, right? So now we have to go for 2 carbonyl groups are there. Now we can go for number 1, 2, 3, it is a 4, it is a 5, it is a 6, it is a 7, it is a 8, right? So here both are aldehydes and groups, right? So dialdehydes, right? If you go for here, which one is alpha carbon? For example, one is substrate means it gets a negative charge, it gets a positive part means here alpha carbon only this one. So this one means where it is acted joined here, this carbon ion forms joined to here, this hydrogen is joined here. So which number is formed? 1, 2, 3, 4, 5, 6, 7. So here is 7-member ring is possibilities are there. So 7-member ring is possibilities are there. So only this type of case, right? Remaining open chain or aliphatic related molecules, when you can go for check it. The 5-membered or 6-membered rings are more stable than remaining position or remaining ring formula. Like 3-membered is unstable, 4-membered is also unstable, and 7-member also unstable for open chain diketones, right? And dialdehyde or ketone and aldehyde. This is a very important topic. If you go for aldehyde and ketone means which one is more reactive means aldehyde is more reactive. It acts as a substrate, and keto group is acts as a reagent. So reagent means the alpha carbon or forms carbon ions. This forms carbon ion or this side also carbon ions is forms. Right? So one more important case. If you go for unsymmetrical ketones, So unsymmetrical ketone means how many products are possibilities are there here. So unsymmetrical ketone means CH3. I am taking C double bond O. Here is CH2. Here is CH2. Here is I am going for C double bond O, CH2 and CH3. They took here what is the major product. Find the major product. Right. Here it is not a symmetrical ketones. So why? Because of here is methyl after keto group is there. Here is which side is ethyl group is there. If you go for first 1, 2, 3, 4, 5, 6, 7. So one side is ethyl, one side is methyls. Right? So you introduce CH2 and CH2. But which one is acts as a substrate? Which one is acts as a reagent here? So it is a methyl ketones. Here is ethyl ketones. Right? So due to that, which one is bulky group? Ethyl group is more bulky than ethyl. It is acts as a substrate. It gets negative part. It gets a partially positive part. Because of that if you take acetone, right? So both are which one is there? Methyl group and methyl groups. If you take acetaldehyde, CH3C double bond OH, here is methyl group, one side is hydrogens. Suppose I am taking for these different groups, CH3C double bond O and CH2 and CH3. So what is the reactivity of these molecules? Carbonyl molecule means acetaldehyde is more reactive because of one is methyl, one is hydrogen. Less steric entrance, hydrogen, small size. Both are methyl groups. This here one is methyl, one is ethyls. It is a bulky alkyl groups. So alkyl group size increases, right? The nucleophile is not easily added to the carbonyl carbons. So that's why this group is less reactive than this carbonyl groups. That's why it forms. It is a substrate. This is a substrate. Substrate means reaction takes place in this position. And here alpha carbon is forms carbonine. Which alpha carbon? If you go for this one in 1, 2, 3 positions. So 3. It is a 3 membered. It is not possible. If you go for this side alpha carbon means 1, 2, 3, 4, 5. It is a 5 membered ring. So it will be involved in the reactions. So what is the major product will be from 1, 2, 3, 4, 5. So it is a 5 membered ring is possibilities are there. 5 member. Right. Suppose if it is a carbanion means it is a side chain is it is added to the this is added to the here means right here we are getting that O H here CH2 group. CH group is next carbon is double bond O, right? It is CH2 group is methyl group also there side chain. You can add the methyl group is side chain. It is joined here, and this OH group also methyl group is there. Here we are getting that methyl group here, right? So now we can go for elimination of water molecule to get stable product, right? So where we are getting that means here methyl double bond O. Here is tertiary hydrogen is eliminated double bond and CH3. So this is the your product or major product. So take care. We have to check it number formation ring. 5 membered or 6 membered. Right? How it gets stable. So check it main 5 membered ring and 6 membered ring. If you go for unsymmetrical ketone, mean you have to check it same method for the 5 membered is possible or 6 membered ring is possible. If you go for inner alpha carbon and outer. So which alpha carbon forms carbonate. Suppose if you go for this one means 3 membered. If you go for outer side alpha carbon means this forms 5 membered. So outside alpha carbon forms carbonate means form 5 membered. 5 membered is more stable than 3 members. Just you can go for the stability of rings. Either 5 membered or 6 members are more stable products. Right? Like that you have to check it. Right? In some different cases are that if you go for CH3, C double bond O, CH2, CH2 and CH2, CH2, C double bond O and CH2 and CH3. So which one is possible here? This one also same. So methyl, one side is methyl, one side is ethyl. Sometimes they're giving isopropyl, different types of groups they have to take it. But we have to check it the bulkiness. If bulky alkyl groups are there means that is less reactive than another one. Right? So it's a less reactive. That alpha carbon forms carbanions. It is acts as a substrate. Right? So thank you.